Hi there. I have put together a small program which simulates a shared ledger network, shared ledger or distributed ledger or blockchain. It's all the same. It's basically the magic behind cryptocurrencies such as Bitcoin or Ethereum. So everything is explained in this post on my blog. My motivation, I explained that I wanted to keep it simple because it's for me to understand the basic concepts, but also I wanted to be loyal, right, to these basic concepts of the blockchain algorithm or protocol. So the code is available on GitHub. Yeah, you have the whole code there. And yeah, so basically in this video I wanted to show an execution of this test class, which basically it just generates the Genesis block. I generate this Genesis block manually. Actually is the same, it's similar concept. Here you have the Genesis block from blockchain, from the Bitcoin blockchain, the original one. You can see that the hash code of this block has, this amount of zeros, and this is very difficult to achieve, right? This is the proof of work on which is based the whole algorithm. So actually, I similarly in my program in this application.properties, I specify how many zeros the hash code of a block needs to have, leaving zeros, in order to be accepted by the rest of the nodes, by the rest of the network. In this case, it's 3, and I have put some sleep statements to slow down the execution. So we can see how this magic number is found, because it tries with different nouns. This is the random number that you add to the block in order to make it have certain numbers of zeros when doing the hash of that blockchain. So yeah, after I generate this Genesis block, then there is already one miner. Here you have it, the full node 1. So the full node 1 is just running on a thread instead of running on a machine, usually big machine with a lot of computing power. You heard about this mining pools in China, which use really advanced hardware and use a lot of electricity, and they compete with other miners to generate the next block in the chain. So this is the same, but I'm just running everything on a Java process. Each miner, it's a thread. So after a little more than 3.5 seconds, I start another miner, another full node 2, and this is when the competition begins, right? These two nodes are gonna compete against each other to generate the next valid block. So far the blocks, they only contain the reward transaction, for the miner to get that number of coins. Going back to Bitcoin, you see here, you see this is the amount of the transaction, 5,000 Bitcoins. This is with all the decimals. This is in Satoshis, I guess. So yeah, it's 50 Bitcoins, right? Yeah. In my case, it's configured here. I decided that for each block, the miner will get 50,000, but you can change this, right? Anyway, so other than these transactions, then the thin clients will submit also transactions. In this case, the thin clients are, the clients that it's similar to a Bitcoin wallet, right, application. So yeah, these transactions, they usually contain a fee. The fee is not explicitly set, but it's the leftover in the source address when the outputs of the transaction are deducted from the balance in that source address, right? So just basically it, right? So we have miners, we have thin clients. Let's execute this. It's very simple, I'm gonna show you, the running configuration. This is the class, Java 8, no arguments. That's it. So let's run this. And we can see that, oh yeah, it's trying to, the blocks are being generated and nouns are being tried. The nouns is, this random number that we add to the block to try to make the hash code have, in this case, 3 leading zeros. So this is it. You see, block 18. So 19 blocks because were generated because the block 0 up to the block 18. And yeah, we can see let me find the first block. This is the Genesis block, right? This is the miner address. And then finally the block 1. This is the first block that was really mined by a full node. This is the address of the miner, okay, -78. And then the second block, it's also the same address, the same miner, the same miner address. So the same process, the same thread, created it. Then -78, also the third, the fourth, the fifth block. But wait, block number 6, we already have a different miner address, right? So finally, after we started this second miner, it generated a block. And yeah, you can see then the addresses were included into the next block and so on. So we can see that the algorithm works, right? We could create a tree, with because each block has a pointer to the parent block, so it's kind of a tree. And each execution will give us different tree and different results, and because it's there is randomness in it. So let's execute it again, and you see nouns, different nouns being tried, and the number of blocks increases. And okay, again 18 blocks. And again, the Genesis block, then this is the miner address, a new address, but this is miner 1, block 2, block. You see, before we needed to wait till the 4th block, I remember, to find a block which was generated by the second number. But here, already in block 3, you see, the miner address, it's already different than the previous miner address. So in this execution, you know, the second miner was luckier and got a valid nonce, right? Sooner than the previous execution. So yeah, I mean, I could complicate this more, you know, add more full nodes, add more thin clients, more transactions, and yeah, I should actually maybe represent this graphically, like a diagram with the blocks and what's the parent block and what miner created. So yeah, I'll do that in the future, but I just wanted to show you that this is how it works, right? I mean, miners competing against each other. In this case, both miners have the same computing power, so it's all about how lucky they are. But of course, in real life, in Bitcoin or Ethereum miners, some miners are stronger or more powerful than others, right? So okay, I hope you enjoy this, and yeah, have a look to the code and let me know what you think.